Hello everyone, this is Mr. McMillan, and I'm here today with the instructional video on inverse trigonometric ratios. And this is the last part of the right triangle topics that we're going to be covering. The rest of it is going to be, the rest of this week is going to be review over these concepts for the Pythagorean theorem, special right triangles, and trig ratios. Okay, so in this video, we're going to be talking about how to find missing angle measures instead of missing side measures, okay? And we can't just use the regular trig ratios for that. We have to use the inverse trig ratios because we're actually solving for the angle instead of the side. So our original trig ratios were sine of theta equals opposite over hypotenuse. Then cosine of theta is equal to the adjacent over the hypotenuse. And then our tangent of theta is equal to the opposite over adjacent. Okay, and remember, O is the opposite side from theta, A is the adjacent side to theta, and H is your hypotenuse. O and A are always your legs. So your inverse trig ratios, what you need to do with those is, just like when you're solving an equation, you need to do the opposite of something to figure out something else. Well, the inverse trig ratios are the opposite to your original trig ratios. So, and that helps you find theta. So theta, if you have O and H as your sides, is equal to sine inverse of O over H. So inverse sine, or it's also called arc sine, okay? Then you have theta for your cosine. You've got inverse cosine of A over H. And then for tangent, you have theta equals the inverse tangent of O over A. So here are three important notes about your inverse trig ratios. Number one, they are used specifically to find angles. They are not used to find sides. That's what your original trig ratios are for. So they only find theta. Okay, so if you're looking for an angle, you need to be using the inverse trig ratios in your problem. Okay, so make sure that you're aware of what you need to find. Okay, the next thing is you might also see these referred to as arc sine and things like that. So inverse trig ratios are also called arc sine, arc cosine, and arc tangent. Okay, so make sure you're aware of that when you go and do that. And for your third thing, if you already know theta, you are looking for a side. Okay, and in that case, you will not be using the inverse trig ratios. Okay, so original trig ratios, you set up the equation and solve it. You never use the inverse if you're looking for a side. If you're looking for theta, that's where you use your inverse. Okay, and just the key thing here in Desmos, make sure in Desmos that you have your calculator in degree mode. Okay, that's got to be highlighted because we're dealing with angles. And then in your keypad, remember that if you click the functions button under the trig, you'll see sine, cosine, and tangent. And then right next to it, you'll see sine inverse, cosine inverse, and tangent inverse. Okay, so these are the ones we're going to be using in this video, but you need to know how to use all 6 of these. Okay, so let's look at some examples. There are going to be 4 examples we do in this video as part of the notes. And the first one says, given the diagram below, what is the measure of angle Y? So it wants to know the measure of angle Y. So that is where you know where your theta has to go. So theta is going to go on angle Y. So there we go. Now the next thing is we're going to do the same exact thing we did when we found sides. We're still going to label our sides with O, H, and A. But what we need to do is make sure that we solve it correctly after we set up our equation. So I always like to find your hypotenuse first. You can do it whichever way you like, but the hypotenuse is always going to be the easiest one to label first. So your 18 here is on the hypotenuse because it's opposite of the right angle. So 18 is your H value. And then if we look at 9 here, is that our opposite or adjacent value? Well, 9 here does not touch theta. It doesn't touch theta. You see here that it does not touch theta. So that means that 9 has to be opposite from theta, and that leaves ZY to be our adjacent. Now, we're only interested in these sides that we have, okay? So we have O and H. So we have O and H. So we need to use the trig ratio that deals with the opposite and the hypotenuse. And if you remember SOHCAHTOA, SOHCAHTOA, SOHCAHTOA tells us that sine is our opposite and our hypotenuse. So we're going to write sine of theta equals, and remember we have to write theta because we don't know what theta is. And then our opposite, which is 9, over our hypotenuse, which is 18. So sine of theta equals 9 over 18. As you can see, we're not solving for a side because we already know both of them. So that means we're looking for our angle theta. So we need to use the inverse sine of this to find what theta is. So theta has to equal the inverse sine of 9 over 18. And in Desmos, we're just going to plug that in just like we see it there. So going to theta, or going to Desmos, excuse me, we go to our functions and hit inverse sine, and then we type in 9 over 18, and that gives us 30 degrees. Okay, so for this one, our answer is theta is equal to 30 degrees. So that is the measure of angle Y. All right, number 2. A right triangle is shown below. What is the value of x? And if we look at where x is in an angle position. You'll notice we don't have any letters, but we know that x is inside, so x has to be our theta. Same deal. We're going to be doing O, H, and A again. And if we look here, the side opposite from the right angle is your hypotenuse, but you'll notice that there's nothing labeled there. We'll label it with an H, but we won't need to use H in this particular one. Then we're going to identify our opposite and adjacent side. Our opposite side is the one that does not touch theta. And is that 13 or is it 13.7? Well, 13 here does not touch theta, so 13 is our opposite side, and 13.7 would be our adjacent side. So we know what O and A are, so we need the trig ratio that uses O and A. And as SOHCAHTOA tells us, it would be tangent. So we have tangent Now, theta is x, so I'm just going to put x is equal to O over A. Our O is 13. Our A is 13.7. And since we already know both sides and we're looking for the angle, we need to take the inverse tangent of the right side. So x is equal to the inverse tangent of 13 over 13.7. And if we go to our calculator, to Desmos, we're going to type in inverse tangent of 13 over 13.7. And that gives us 43.4982. And if we round that to the nearest tenth, we would get 43.5 degrees. So x is approximately 43.5 degrees. So for any of these problems, just make sure that you are rounding to the nearest tenth for the most part. All right, if you want to try number 3 and 4 on your own, go ahead, give it a go, and then come back and see how you did. Otherwise, continue watching and see how they're worked out. So number 3, it says a right triangle is shown below. What is the value of y? So y, again, is inside of the angle here, so that's our theta. We're going to identify our opposite hypotenuse and adjacent sides. Our hypotenuse is opposite the right angle. And so we see here that we have h there. It's not labeled with anything. 15 does not touch theta, so that means that it's our opposite side, and 27 is our adjacent side. So again, we're looking for the trig function that deals with O and A, and SOHCAHTOA tells us that that would be tangent. So we have tangent of y is equal to the opposite, which is 15, over the adjacent, which is 27. We're looking for an angle, so we have to take the inverse tangent. And we have 15 over 27 here. So y is the inverse tangent of 15 over 27. And if we go to Desmos and type that in, so the inverse tangent of 15 over 27, and round that to the nearest tenth, it gives us that y is equal to 29.1 degrees. 29.1 degrees. And then finally, number 4, given the diagram below, what is the measure of angle F? So it wants to know the measure of an angle, specifically angle F. So we put theta there. And now we identify our opposite, adjacent, and hypotenuse. The hypotenuse is opposite from the right angle, and this time 48 would be our hypotenuse. And if we look here, 17 touches the theta, so that is our adjacent, and our opposite side has nothing labeled on it. So we have A and H. So which trig ratio uses A and H? That would be cosine. So we have cosine of theta is equal to A, which is 17, over H, which is 48. We're looking for theta, so we take the inverse tangent of 17 over 48 to find out what theta is. And if we go to our calculator, we're going to type in inverse cosine of 17 over 48, and we get that theta is approximately 69.3 degrees. So 69.3 degrees. Okay. And that's going to do it for this video, guys. The IXL assignments have been posted online. These are R.8 and R.9, both to a minimum score of 60. I also said in the description of it that if you get both of them to an 80, I'll give you 3 extra points on the test. And if you get them both to a 90, I'll give you 5. Okay, so work on those, and if you have any questions about anything, please let me know. Also expect a video on the practice trig problems from the other day, those 20 problems that I assigned for practice. Okay, those will be in an answer key video as well. And from now on, all of these videos will be on the YouTube channel instead of the Google Drive because of issues with the Google Drive player. Thanks, guys, and I will see you in the next video.